Hello everyone, today I will be talking about how to assign formal charges. Assign the formal charge, we need to subtract all unshared electrons such as the lone pair plus half of all shared electrons that happens due to the bonding from the number of the valence electrons of the neutral unbonded atom. So if I looked at, for example, on that case for the oxygen in this compound, you could see that the oxygen is satisfying the octet rules, which means it have eight surrounding electrons. If I looked at the eight, how I can count the 8 electrons, I have here four unbonded electrons plus I have C double bond O. Each bond I will count it as 2 electrons. So in that case, I have between the C and O, I have another 4 electrons. So we could see that there are 8 electrons surrounding my oxygen. Now let's assign the formal charge for the oxygen atom itself. So when we assign the formal charge, we need to, so the formal charge would be equal to, in that case for the oxygen, would be equal to the valence electrons. I have 6 valence electrons for the oxygen, would be minus the number of unshared electrons, which is equal to 4. I have here 2 lone pair, which means I have 4 unshared electrons, plus the half number. I will multiply half by the number of shared electrons, which are 4 electrons. So each bond contains 2 electrons. This means I have 1, 2, 3, 4. I have 4 electrons. So the formal charge in that case would be equal to 0. Let's assign for this compound instead. So if I looked at the formal charge for that compound, I have the same for the oxygen. If I looked at the formal charge of oxygen, I have here valence electrons is equal to 6, would be minus the number of the electrons unshared, which is equal to 2 electrons. And this would be plus half multiplied by the number of the bonded electrons, which is equal to 1, 2, 3, 4, 5, 6, equal to 6. This means I have the formal charge here is equal to plus 1. So this is why we write this plus above the oxygen. If I try to assign the formal charge on for this compound, so the formal charge would be equal to the number of the valence electrons minus the unpaired electrons, which is equal to 6, plus half multiplied by the shared electrons, which are 2. So I have 2 shared electrons. This means I have here minus 1. This is why we write this minus above the oxygen to indicate that I have formal charge, which is equal to minus 1. You have to look again. Formal charge is different from the octet number. So if I count the number of electrons surrounding the oxygen in this compound, you could see that they are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 electrons still surrounding my atom. But the formal charge is the difference in the charge between the valence electrons and the actual electrons surrounding my charge is equal to minus 1. Now let's try to solve this example. Let's try to calculate the formal charge for that case for the carbon. So formal charge for the first carbon atom is equal to, I have the valence electron of the carbon is equal to 4. This would be minus the, I don't have any unshared electrons, but I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 electrons which are shared. I'll multiply them by half. In that case, this means my formal charge for the carbon is equal to 0. This is for this carbon. Now for that carbon, if I try to calculate, so this is carbon number 1. Carbon number 2, in that case, if I calculate the number of formal charges, and in that case, so formal charge for second carbon would be equal to the number of electrons, unshared electrons. In here I have also the valence electrons are equal to 4, and I don't have any unshared electrons, but now I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 multiplied by half, which are my bonded electrons. In that case, I also have 0 formal charge on that carbon. If I try to look for formal charge for that carbon, the third carbon in that case, so formal charge for third carbon would be equal to the valence electron equal to 4, and if I calculate I don't have any unbonded electrons, but if I calculate now the number of bonded electrons are 1, 2, 3, 4, 5, 6. So I have 6 bonded electrons. I multiply them by half. This means this would be equal to 3. So 4 minus 3 is equal to plus 1. This means I should write plus over the carbon. If I try for oxygen, the last one, so the formal charge for the oxygen is equal to the valence electrons of oxygen are equal to 6, and in that case the number of unpaired electrons are equal to 4, and the number of the unpaired the shared electrons are 1, 2, 3, 4. So I will multiply 4 by half, which means it's equal to 2. This means the total number of electrons in that case are equal to 0. You could see that the only formal charge in that case would be equal to 0. So this is the only part where I should look at the formal charge to write down the formal charge for my compound. Now let's try for this compound. In here I have nitrogen, carbon, and the carbon. If I numbered my structure from this side, and I have here, this is the first carbon and this is the second carbon for the, so the formal charge in that case for my first carbon would be equal to the valence electrons of carbon is equal to 4 minus the there is no unshared electrons, but there is 1, 2, 3, 4, 5, 6, 7, 8. There are 8 electrons which are shared. I'll multiply them by half. This is why I have only I have 0 charge on that carbon. If I look at the other carbon, it is also 1, 2, 3, 4, 5, 6, 7, 8. There are 8 shared electrons, and in that case, if I looked at the valence electron is equal to 4, this means I have also here 0 formal charge. If I look at formal charge for nitrogen, and for nitrogen I have, on that case, I have 5 electrons. So the 5 electrons would be minus the number of unshared electrons are equal to 2 plus the number of shared electrons 1, 2, 3, 4, 5, 6. I have 6 shared electrons multiplied by half. This means I have the total formal charge are equal to 0. If I look at the oxygen, in that case the formal charge for oxygen would be equal to the valence electrons of oxygen are equal to 6, and the formal charge would be equal the unshared electrons are equal to 6, and there are in that case there are 2 shared electrons. I'll multiply them by half. This means I have, in that case, I have minus 1 formal charge. So I should write down minus on that oxygen in that side. Now, if I try to calculate the formal charge in this compound for this carbon, it's equal to 0, and that oxygen is equal to 0. But let's calculate the formal charge for this carbon. So the formal charge is equal to, in that case, the valence electrons of carbon is equal to 4 minus the number of unshared electrons are equal to 2 plus I will multiply the bond electrons by half. Shared electrons are 1, 2, 3, 4, 5, 6. I have 6 shared electrons. This means I have here minus 1. So this carbon I should write down minus over this carbon. So I have minus 1 formal charge. Now let's calculate for this compound, and in that case I have here this carbon, these 3 carbons have 0 formal charge. But let's try to calculate formal charge for the oxygen. So formal charge for the oxygen is equal to I have valence electrons are equal to 6. This would be minus the number of unshared electrons, which is equal to 6. This would be plus half the number of the shared electrons, which are 2. This means I have minus 1. So I should write minus over this oxygen. Let's look at this compound and let's assign the formal charge for that carbon. So in here, these two carbons have 0 formal charge. For that carbon, the formal charge is equal to, in that case, I have the carbon have valence electrons, which is equal to 4, minus the number of unshared electrons is equal to 0. This would be plus half the number of the shared electrons, which is equal to 6. This means I have here 3 minus 4 is equal to plus 1. So I have here plus, I should write it above this carbon. Let's try to calculate the formal charge for that compound. In that case, for this oxygen, I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 electrons to satisfy the octet rule, and the formal charge for oxygen would be equal to the valence electrons minus the unshared electrons plus the half of my shared electrons, which is equal to 1, 2, 3, 4, 5, 6, 6 electrons. So it is equal to, in that case, is equal to 3 plus 2 is equal to 5, 5 minus 6 equal to plus 1. So I should write plus over this oxygen. By that, we came to the end of the video. Thank you and goodbye.